Good morning, I am Brian Pamuti. Today I will present our research entitled Low Density Parity Check Code LDPC for Enhancement of Physical Light Communication Performance. We have three authors in our research. First, me as the first author, and then second is Adin, and third is Nahwan Mufti Adiansyah. We come from Telkom University with optical communication laboratory. So in this presentation, we have three sections. The first is motivation, system model, and then result. First is the motivation why we should research about Wi-Fi or light fidelity. First, bandwidth of the needs of bandwidth every years is increased, and then we know from this picture that the increase exponentially will grow, and then in 2024 is the peak of communication electronic with green section, and Wi-Fi is one of the electronic. And then why we have to use light fidelity? First, radio frequency or radio waves are expensive, and then we know that LED can buy in markets near from our home. Second, gamma rays are harmful for humans, and then ultraviolet light can be considered for communication technology purpose, but without people. This is the better, different aim with this Wi-Fi. Infrared can only be used with low power, so we can assume that the future is for the Wi-Fi with LED. And then this is our motivation. First, one of FSD or forward error correction or forward error control technology is LDPC, one of the FPC. It results in better performance when compared to other codes and approach Shannon limit. This is the result of the first research, and then the second, using DCO, OFDM, or direct current bias optical orthogonal frequency division multiplexing. Second researchers show that LDPC was better performance than encoded of DC bias. And then QC-LDPC code can save memory and avoid the number of bits for in matrix construction. But if we use DCO with this multiplexing, we have bigger complexity than we use simple code line coding like n transit, non-return to zero, or on-off key. And this is our propose. So we propose simple G-matrix for encoder, and then we use bit clipping for the decoder in stepper side. The PLC system or the block diagram illustrates in this picture. So this is the data without code, and then we coded the data with the rate 0.5. So this is OK modulation if bit 1, and then direct current drive will open, and then the LED will have a light if OK the bit is 0, and then the LED will turn off. So this is like a flicker. One for turn on, O for turn off. And then this is a PLC channel model. In this section, this is a PD or photodetector, positive, intrinsic, negative in receiver side. And this part will return. This is the electrical, and then LED use optical signal with pin. The optical signal will be converted to electrical signal. And this is the modulation okay, but in this modulation the real data haven't out yet, and then we have to use the coder to extract the real data. And the last, we will compare the input data and then the receiver data. So we have EER or bit error rate to present how much error obtained in this scenario. So okay, this is the G matrix. So this is the matrix identity. So we use encoding and decoding in the QC-LDPC codes encoding process. The matrix generator G obtained from the parity check matrix H, and then the Gauss-Jordan elimination method is used to a matrix generator G for H given the encoding step. So this is the G matrix, and then this is the P identity, identity, and this is the matrix identity. So this is the C or for the word, U is the real information, and then G is the G matrix. So we can multiply the real data and then the matrix. So we have the for the words with for the words it will be sent in PLC. So this is the decoder in the RX with bit flipping. So bit flipping is a decoding method, requires XOR and a comparison to perform its operation. The bit flipping method is a hard precision decoding, so this is a simple, not a soft precision decoding. For each bit reset, an important step in the iterative decoding algorithm is passing message between nodes on a tenor graph. In bit flipping, the message nodes send binary message to the check node. Then each node sends a message to message node connected to the tenor graph, and then check whether the parity check is fulfilled or not. If not fulfilled, so the bit will change, like the name bit flipping, and if fulfilled, so the bit is correct. So just simple like that. And then this is the parameter of simulation. We have around 100 bits, 100,000 bits. And then the modulation is energy okay. We have for the rate half for the rate. So for the words will twice as the real data transmit with 7 watt, and then the noise is okay. And we try to iteration in the decoder with 3 scenario, 5, 10, and 15. Okay, now we in the result. So this is the result of our research. So the figure show that the comparison between uncoded OK and QC-LDPC code in the same condition, and the longest to find the longest descent to receiver. So this is the target. Target there is 10 power to minus 3. So if we check to this line, if we use LDPC, we obtain 11.6 meters, and then if we use uncoded for modulation, we obtain 10.8. This is the power receive between the BER. So in this picture, you can see that the OOK with LDPC codes have a 27.5% power in the pair, and we have a coding gain about 1.4 dB. And then this is the last. We try to different number of iteration in the decoding receiver side. So in this picture illustrates that the increasing number of iteration affect to high complexity for LDPC decoding. But we have a better performance if we try to bigger number of iteration. So this is our conclusion. We found that QC-LDPC code is better choice of decoding technique in order to reduce bare for enhancing distance by 7% compared to uncoded VLC. And then in minimum receive power, so the bare with LDPC code up to minus 46.5 dBm is very lower than uncoded or without coding. And then in this research we have coding gain around 1.4 dB. So in addition, the number of decoding iteration also involves in enhancing VLC system. The increasing number of iteration produce better ER performance. So it takes longer time to decode. So this is one of trade-off in our research. Okay, one regards and definitely thank you for your attention and have a good